Hello, so welcome to video 2 where we're going to talk about one population proportion confidence intervals. So the general gist is, remember, for confidence intervals, what we're trying to do is estimate a value for a parameter um, that we don't have access to, right? The parameter is something that we just don't know. What we're going to from the population, what we're going to do is draw a sample from the population to be able to create an interval of plausible values for that particular entity. And so, what we're going to look at for this particular video is a confidence interval regarding the population proportion. So, remember, in terms of assumptions, we know that n times p hat has to be greater than or equal to 10, and n times q hat, or n times 1 minus p hat, has to be greater than or equal to 10, and the data must be random. The data must be random, okay? That's really, that's key. It's really important. And so, in order for us to create a valid confidence interval, those three conditions have to be met. Those three conditions have to be met. And so, how I approach this confidence interval is pretty straightforward. Okay, in order for, at least in terms of calculations, we have three things. We have the point estimate, okay, which is essentially the sample statistic. We have the standard error, which measures how the actual statistic varies within the population or within the sample. And then we actually have the critical value, and that's the number of standard errors away from the actual point estimate. So for here, the point estimate is going to be, or at least the sample point estimate is going to be the sample proportion x over n. So it's going to be the number of values, or the number of the frequency of what we're trying, the level that we're interested in, divided by the sample size. And then the standard error, right, is calculated in this manner: the square root of p hat times q hat over n, or the square root of p hat times 1 minus p hat over n. And then you have the formula, as I said before, the point estimate plus or minus critical value times the standard error. I do not believe in the book. I don't believe in the table. I don't believe in the table. I don't believe in the table. So you're gonna have to find this value either by looking up on R, looking up on Google, or most likely if it's on an assessment, I'll be given to you, because that's not what's important. So based on your experience, take a pause, right? And we should already have had experience with this confidence intervals. Take a pause and answer these two questions. Answer these two questions. So ideally, you would have paused the video, right? And so you should know what happens to the interval if n increases. What happens? What does that even really mean? So if n increases, that means that we get more data. We're fortunate enough to get more data. And again, we're assuming that everything else is held constant. What does it mean when n increases? Ideally, the interval should do what? The interval should shrink. The more data we get from the actual how do I say this? From the actual population, the more accurate, or one can say, that will be in terms of our estimate of that parameter, of that proportion. Okay. So what happens to the interval as the interval? What happens to the interval as the level of confidence increases? Okay, as the level of confidence increases, what's going to happen to our interval? So ideally, you would have already answered that. The interval will widen, right? The more the more confident that you are in terms of the parameter of interest, ideally that interval will widen. Okay, and so some takeaway messages from these two questions is that you should know, or at least you should be able to understand how the confidence interval is being impacted in terms of sample size, right, and the level of confidence. So the inverse is going to be the opposite. So when n decreases, the interval would widen, right? Because there's a little more variability in terms of knowing what the parameter is. And then when it comes to level of confidence, if it were to decrease, we would actually see that the interval would shrink. Okay. So what we're going to now do is look at this confidence interval for one population. And so this is the statistical process. And this is me asking you every single particular question, not that I can ask, but that is relevant in terms of a statistical question. So state the statistical question. What's population of interest? You can pause and read the rest of it. But what we're going to do is actually go through a problem, a real life problem that we might be interested in, and go through this process of answering these questions. So let's read the prompt, and then I'm going to have you all pause the video, and then answer these questions. Okay, so I'm going to just bold this. Yeah, I'm gonna bold it. So pause the video and answer these questions. Okay, so here let's go ahead and ask this. So how many Cal Poly or CP students left the United States during the summer of 2022? So say we have a random sample, ideally it's a random sample, 72 students, right? Of which 39 left the United States. Okay, create a 90% confidence interval for the proportion of CP students, Cal Poly students who left the US during the summer of 2022. Okay, so we're going to give you the critical value, as I said. The critical value here, right, is 1.6449. Okay, 1.6449. Okay, so pause the video and go through these questions. Hopefully, it's self evident. So, you're going to answer each one of these questions in the context of this problem. Okay, so go ahead, pause. All right, so now that we're back, okay, so one of the first questions, I'm just going to highlight it as we go through it. Okay, one of the first questions, state the statistical question. What that is going to be the proportion of Cal Poly students that left California. What is the proportion of Cal Poly students that left US in the summer of 2020? Okay, that's the statistical question. State the population of interest is going to be the Cal Poly students. The observational unit is going to be a Cal Poly student. State the sample was taken randomly. What's the variable of interest? Whether a Cal Poly student left the United States in summer of 2020 or not. If you did not provide all that detail, it would be wrong. You'll get points taken off. So you need to be as specific as possible. What's the variable of interest? Categorical binary. State the summary statistic. How do we summarize the information? It's going to be this sample proportion. P hat is equal to 0.54. The best way of actually visualizing it, I would prefer a bar plot. Okay, I prefer a bar plot. I said pie chart, but I prefer a bar plot. I'm gonna let this go because my hand's getting tired. All right, that's good. Okay. State the inferential technique and the assumptions. And so here it's a confidence interval. The assumptions n times p hat greater than or equal to 10. Oh, that assumption is met. N times q hat greater than or equal to 10. Oh, that assumption is met. So we're good here. And we also say that the data was collected randomly. Okay, so we want to calculate the point estimate. So it's the this is the frequency of the level of interest, which is if they left the United States, right, divided by the sample size, which is I believe 72. We get 0.54. State the standard error. That's the standard error. State the critical value. It's given to us. Okay. And then here's the math. And then here's our conclusion. And so forth. So I'll be posting these answers if you didn't get to write it down. But let's actually go through it a little deeper. So the critical value is the number of standard errors away from the actual center, which is given to you 1.6499. And again, the distribution is a z distribution. I didn't mention that earlier, but I would have said that in class. Continuing on, in terms of the margin of error, it's just the intermediate step regarding the confidence interval. It's the critical value times the standard error. And there we go. And then we do the math. So it's really important that we are cognizant of this interpretation of what we just calculated. We don't just do calculations for fun. We need to be able to interpret what these calculations mean. We are 90% confident that the population, I didn't even put that there, the population, I'll type that so you all can, emphasize this on your quiz, on an exam, the population, if I can spell right, thank you, Google. We're 90% confident that the population proportion of all Cal Poly students who left the United States in the summer of 2022 is in between 0.443 and 0.637. That's a wrap. Thank you all for your time, and I hope you have a great rest of your day.